A very interesting MCQ type problem from particle dynamics and from the chapter work, power and energy, and this is from UPSC Prelims 2004. And in this problem it is says that a particle can descend along a straight smooth tube from A to the point B, where AB makes angle 60 degree with horizontal, and there is a smooth semicircular tube whose diameter is AB from A to B. Okay, so we first draw a complete circle, and now we draw a semicircle. This is A, this is B, and we draw the horizontal line. This is horizontal, let this be BC, right? This is C, and here it is given that 60 degree, and let this is the center of the circle, and since it is given that it is semicircle, so it must be right angle. This is 90 degree, so this is 30 degree, right? This is the complete figure. If V1 and V2 be the velocities of the particle having reached at B in two cases. The first case is when descend along the straight path. This is the straight path. When the particle descend along this path, here velocity V, this is equal to V1. And while descend along semicircular path, this is the semicircular path. When the particle descend along this path like this, and then V, this is equal to V2. These two velocities are at the same point, that is the point B. And where AB, this is equal to L, it is given by AB, this is equal to L, this is the diameter. Then we have to find the correct alternative. Four alternatives are given here. We first consider the line AB, or the motion along the straight line. Then we use the formula V square, this is equal to U square plus 2FS, right? This is the formula of motion in a straight line under constant acceleration. And since the particles start from the point A, this is the initial point, so here U, this is equal to 0 in both cases, when particle descend along AB and descend along the semicircular path ACB, right? Now we put here, this is 0, so, and also this is VU1, this is VU1 square, this is 0 plus 2 into. Here the particle falls freely under gravity, so here gravitational force act along vertically downwards. This is the direction of gravitational force G per unit mass, and since this is the angle 30 degree, so the component of G along the line AB is obviously given by G cos 30 degree, and this is equal to root 3 by 2 into G. Okay, and we put F, this is equal to root 3 by 2 into G, and here S, this is equal to the length of AB, which is given by L, right? So we put here two value. We first put F, this is root 3 by 2 into G, into the value of S, this is L, so velocity is given by root 3 into GL. This is V1 square. Okay. Now when particle descend along the semicircle, we have to find here the velocity, and in this case, how to find the velocity? For this case, we use, here already we write result use, we use the principle of work and energy, or it is also said that energy equation. What is energy equation? Energy equation is given by change of kinetic energy. This is the work done by the external force. And here in the second case it is given that the velocity at the final position is v2 and velocity at the initial position is 0. So change of kinetic energy, obviously this is half m v2 square minus 0 square. If we take m be the mass of the particle. Okay, this is the change of kinetic energy. And now we have to find the work done by the external force. What is the external force? External force is given by G. Here only gravitational force act here. And we have to find the work done. Work done means W. This is equal to force into displacement. So here force is AmG, because we take here the mass is m, so force is AmG into displacement. What is the displacement? Displacement is AC. Okay, and the value of AC from the triangle we get, this is the hypotenuse, this is 60 degree, this is perpendicular, so we get AC by L, perpendicular by hypotenuse, this is sine 60 degree, right? So AC, this is L into sine 60 degree, this is L root 3 by 2. Now we get the work done, this is mg into root 3 by 2 into L, and we put this value of work done here. This is given by mg root 3 L by 2, mg root 3 L by 2. Half and half cancel out from the both side, m and m cancel out, so we obviously get b2 square, this is equal to root 3 into gl. So we get two results, v1 square, this is equal to root 3 into gl, also b2 square, this is also root 3 into gl. Okay, so we see that our option number A, this is the correct one. Very interesting problem. We consider here the motion in two way. Okay, and we have to find the velocity into s. Right? Thank you and keep watching Math A to Z.